evening. My name is Amos Tarfa, and tonight I'll be talking about the tools for mastering mathematics, which is a tool that we put together a few years ago to help students change their attitudes to begin to enjoy mathematics and then apply themselves to master mathematics. I personally believe that mathematics is a beautiful science. I believe that people should strive to master the principles in mathematics. Now, anybody would say, or others might say, that music is beautiful, art is beautiful, and I'm not going to dispute that. I believe that music and art are beautiful forms of human expression, but I believe that mathematics, in the way it's being taught sometimes, has caused some people to lose interest in it. I remember reading a paper where someone talked about, imagine if we taught music in such a way where we focused on the notes and just focused on the theory, music theory only, for a long period of time, instead of allowing people to enjoy music. And I remember that, instead of allowing them to enjoy the classical or the classics or, the works of Handel and Beethoven, and just allow them to study it from a different perspective. Now, that author was bringing a point where they were saying that the way we teach mathematics sometimes involves students learning principles that have no connection sometimes to other things, and it just causes the students to lose interest. Now, it's important to know that there are certain things in life that we do where we don't have a reason at the moment for doing them, but they help us build character, they help us build other skills that will help us later on. So I'm not saying that we should only be interested in things that we have that have application right away. I am saying that we should strive to find ways to engage people to have an interest in the subject material, give them the tools, and give them a path that leads them to master those principles. These are all things that have to come into play. We have to teach with an expectation that the attitude must be changed, and we also have to give them the tools to use after the attitudes have been changed. So, the Tools for Mastering Mathematics, which is a book that is divided into three parts. I wanted to call it a booklet, but it's technically a book that is divided into three parts that addresses different aspects of helping educators and administrators and teachers and students to just have a new appreciation for mathematics. And I'm going to go through some of these things in my series here. I'm going to have a series of videos talking about the principles that we discuss. Some of them are principles you might have heard from other authors as regards to mastering mathematics. So in this first video, I just want to briefly introduce you to the table of contents and to the cover of the book. So this is the cover of the book. It clearly states that we want to help teachers, students, curriculum writers, administrators, and anyone else, and those helping students. We want to work with them to encourage students to excel in mathematics and beyond. This project was done with Nathan Gersett. So Nathan Gersett and myself put this together a few years ago. So let's go to the table of contents. And please, if you are interested in studying this or going more in depth, let me know. My email will be available at the bottom in the video. So here's the table of contents. The first part of the book talks about philosophy of mathematics, or my philosophy of mathematics. And this is where I introduce people to some of the reasons, or the reason for why this project exists. I believe that one of the reasons that this happened was I was teaching Algebra 1, Geometry, and Algebra 2. And I realized that the concepts in those three courses, between those three courses, there's a lot of overlap. And there's nothing wrong with duplicating concepts. But we have a problem where people are studying for the ACT, which is something that we teach at the Learning Institute for Excellence. People are studying for the ACT, and some of them still don't know how to graph. Now, keep in mind that people learn to graph in about 4 classes in a row. They learn it in Algebra 1, they learn it in Algebra 2, they learn it in Geometry, they learn it in Pre-Calc. And some people learn it in Pre-Algebra. That means for 5 years, students learn to graph. And yet, we have students who cannot graph. They cannot graph in the slope-intercept form. That tells me that duplication is not going to solve our problem. We need to change the attitude so that students take each concept and say, I'm going to master this concept like I know my name. And they go with intensity and work hard rather than saying, yep, I'm done with 6th grade math now. I'm going to move on to 7th grade. I got a C in most of the chapters, but I'm going to be okay. No, you wouldn't be okay, is what the student needs to realize. You wouldn't be okay because math concepts build on one another. So these are issues that students have to take seriously in realizing the nature of mathematics. And that's what we discuss in the first part of the book. What is the nature of mathematics? How do we master mathematics? We discuss that in detail, and we will make more videos on those issues. The second part of the book is a reference book. Because I believe personally that forced duplication does not lead to mastery. Forced duplication does not lead to mastery. What leads to mastery would be more of something that another author wrote called deliberate practice. I believe deliberate practice can help people to master concepts. We'll discuss that in the future, but I just want us to keep that in mind. Just making a student to learn a concept year after year for 5 years in a row does not guarantee that that student will master that concept. So that's important that we visit that issue. How much duplication should we have? And if we can remove duplication, some people tell me, well, Amos, what if I forget some principles that I learned before? Well, that's why we have a reference book. And there's Google, there's resources that people can refer back to. But in this book, we go through some concepts where we want the students to always have ready to go. For example, the rules of exponents or properties of exponents. Every student should be ready to use those principles, no matter what math class you're in. See, math is not a subject that can be divided into grade levels. That's not the way it was designed. I understand that we have to do that today because of the structure of schools and so on. Okay, I get that. But we have to also have somewhere in the back of our minds that math principles are not necessarily by nature a grade-based issue. They are a mastery-based issue, such that you can have somebody who is 17 years old who can't add fractions. So what should he be doing? He shouldn't be doing math for 17-year-olds. He should be doing math that will lead him to be able to add fractions, so he can move on to the next concept. And you can have somebody who's 7 years old who is doing differentiation in calculus. If they are able to do it, then let them do it. Again, I understand that this raises some interesting concerns, but my point is, let's at least be honest with realizing the nature of mathematics. And then let's give people a reference tool that they can go back to. Rules of exponents, any day, any time. If a student says they've gone through Algebra 1, then they should know where to go to refer back to that concept. And I hope that as we study these things, you'll see where I'm coming from in terms of refining mastery. So, the last part of the book is, what if we found somebody, and this is, again, this is a long list, so we can scroll down and see more, but what if we found somebody who says, okay, Mr. Tarfa, I want to learn all the concepts in mathematics. I want to master them so that when I go into calculus, it's a much easier ride. Well, it doesn't matter how old they are, but if somebody comes and says, I want to master all the principles of mathematics, and I ask them, have you ever done mathematics? And they say, no, I haven't. Okay, well, let's start from the beginning. Let's talk about counting. Let's talk about basic things. Let's talk about addition. Let's talk about subtraction. The point is, they can go through this roadmap that just leads them from one thing to the next. It doesn't matter how old they are. It doesn't matter what grade they're in. It depends on their ability to apply themselves. I'm going to add one more thing before we finish this first video. There's all these concepts, and you would notice that these concepts are concepts from kindergarten all the way to pre-calculus. And as I said, there's a few more concepts at the bottom. This is kindergarten through pre-algebra, and algebra 1, geometry, algebra 2, pre-calc, all contained in this list. And then all the student has to do is to take each one of these concepts, and in our book, we actually expand on each one of these concepts in the third part of the book. But you take each one of those concepts, you type it into Google or YouTube or Vimeo, and you get a video explaining that concept. And we have videos on some of these, and we will be making more on each one of these topics. But the thing that is important is that we have tools today. What students need today is not so much just the information. They need the inspiration that will then get them to get to work. And here's why I'm saying this. That same summer that I taught Algebra 1, Algebra 2, and Geometry, I realized something. When a student is inspired and cares, there's almost no limit to how far they can go. So when you take a student that is willing to apply themselves, when you take a student who says, I want to do well, I want to give my best, then there's one thing that is essential. And this is one of the things that I cannot. Now, I grew up in Nigeria, and I write a little bit about the math background we have and the training we receive in most schools in Nigeria in the book. But one of the things I would say is this. We cannot take 3 months off from any activity that requires regular practice and expect to be just as good in that activity after those 3 months. We can't do that. How often do basketball players take 3 months off from playing basketball? How often do chess players take 3 months off from playing chess? We can't do that with math. And if we encourage students and inspire them and show them the relevance and give them the tools and they keep learning through the summer, think about how far they will get in their mathematics learning. Think about how they will be less likely to be frustrated because of not remembering what they did last year. So one of the practical steps of this project is to say, if something is not working, then let's face it and let's deal with it. And our current system in mathematics in many places in America and in Europe and all over the world, our current system is not working. We need to figure out how to inspire the next generation of Isaac Newtons, the next generation of Albert Einsteins, the next generation of curious learners who apply themselves to be the best that they can be. And I hope that you'll join me on this journey in helping more children across the world to enjoy mathematics, to love the process, and to apply themselves to it. Thank you for your time, and I look forward to sharing more from this book.